Hey guys, so today we are going to discuss about the question called as count unreachable pairs of nodes in an undirected graph. So let's start reading the question. So you are given an integer n and there is an undirected graph with n nodes number from 0 to n minus 1. So what they're trying to say is they will be giving you an integer n which represents the number of nodes inside an undirected graph, and the nodes inside this graph are represented from 0 to n minus 1. So you are also given a 2D integer array called as edges, where edges of I is equal to ai comma bi, which denotes that there exists an undirected edge connecting nodes ai comma bi. So along with the number of nodes inside this graph, they will be giving you the edges, which is in the form of a 2D array. For example, let's say a comma b, which actually means there is an undirected edge between a to b, which actually means b to a is also accepted because this is an undirected edge. So you have to return the number of pairs of different nodes that are unreachable from each other. So before getting into the unreachable pairs, let's know what is reachable. Instead of knowing about the unreachable, let's try to get to reachable. For example, let's say we have a graph. Let's say we have 0, we have 1, and we have 2. So 0 is connected to 1 and 0 is connected to 2 and 1 to 2. Let's know what are reachable pairs in this graph. So here I can say 0 and 1 is a reachable pair, and 1 and 2 is a reachable pair, and 0 and 2 is a reachable pair. How am I saying they are reachable? If at all there is a path between two nodes, then that pair is called as reachable pair. For example, let's say from 0 to 1 there is a path, right? From 0 to 1 there is one path, and from 0 to 1 there is another path, from going from 0 to 2 and 2 to 1. So there are two paths. So that's the reason why 0 and 1 are reachable pair. Similarly for 1 and 2, from 1 to 2 there is a path directly, or else we can go from 1 to 0 and 0 to 1, 0 to 2. So this is another path. So these are this is also reachable. So now let's see about 0 comma 2. So from 0 to 2 there is a path directly, or else you can go from 0 to 1 and 1 to 2. So there is another path. So that's the reason why these are reachable pairs. So you might have got a doubt, like why not 2 comma 0 is a reachable pair? Suppose it is reachable, but we are making sure we don't have any duplicate pairs, because if 0 comma 2 is reachable pair, then 2 comma 0 is also a reachable pair. So we don't want to make any duplicate pairs, right? So that's the reason why we are not taking duplicate pairs. So we got to know what is reachable. So now let's know what is unreachable pairs. Unreachable pairs are nothing but exactly opposite to reachable pairs. So what is reachable? If at all two nodes are there is a path between two nodes, then they are reachable. So unreachable is nothing but if there is no path between two nodes, then those two nodes are unreachable. That's it. So for example, let's say we have something called as 3, an extra node for the given graph. So now 0 and 3 is unreachable pair. How am I saying that? Because there is no path from 0 and 3, right? Because this is a separate component and this is a separate component. So if at all there is no path between two nodes or two pairs, then that pair is an unreachable pair. But even 0 comma 3 is unreachable, and 2 comma 3 is also unreachable, and similarly 1 comma 3 is also unreachable, because there is no path between 1 comma 3, and there is no path between 2 comma 3, and there is no path between 0 comma 3. So that's the reason these are unreachable pairs. So now let's get in detail about the question, about the solution. So let's take another example. So this example is slightly different from the previous example, but almost similar, because I have added an extra component which is 3 and 4 here. So I have a question. So how many maximum pairs we can form with n nodes in a graph? For example, we have n is equal to 3, and how many we can form at max? How many pairs we can form? Which is n into n, right? So which is gonna be 9. So for example, let's say we have 0, we have 1, we have 2. So these are 3, right? 3 nodes. So we have 3 nodes like this. Let's consider like this. So from 0 to 1, this is gonna be one pair. From 0 to 2, this is gonna be one pair. So again, from 1 to 0, this is going to be one pair. From 1 to 2, this is going to be one pair. I'm considering duplicates as well this time. Let's assume we can take duplicates. We are trying to find at maximum pairs we can form. How much maximum pairs we can form? So now again, from 2 to 0, this is one pair. From 2 to 1, this is one pair. And also there is a self loop also as well, which is from 0 to 0 there are going to be 1, which is going to be from 0 to 0, and 1 to 1, and 2 to 2. So this is how the maximum pairs we can form with n nodes, which is going to be 9. So let's take, so 1 2 3 4 5 6 7 8 and 9. So if at all there is there are n nodes, then we can form n into n maximum pairs we can form. So if we get to know the total number of pairs we can form, and if I remove the reachable pairs from them, won't I get unreachable? Of course we can get, right? So now this is the main formula. Like if you remove the reachable pairs from the total pairs, then we can get the number of unreachable pairs. So that's the main formula we can achieve from this. So now how do you find reachable pairs? Like for example, you can say 0 and 2 are reachable, right? 0 and 2 are reachable, and 0 and 1 are reachable, and 1 and 2 are reachable. And these are only reachable if at all they are connected, right? If at all they are not connected, then we cannot reach from this. There will be no path between these two nodes. So can't I say if there is a component connected in this way or in any other way, component is nothing but nodes that are connected to each other. Like so example, these are two graphs. So this is one component, this is another component, because they are connected with each other. So these are connected with each other. So these two won't be a component. I mean, these two will not be a component, because if at all this entire thing is a component, there should be an energy between these two, right? So this is not a component. So this is a separate component, and this is a separate component. So all the nodes which are in a single component are reachable, right? So because this is reachable to this node, and this is reachable to this node, so this is reachable to this node. If at all they are in a single component, so all the nodes in a component are reachable to each other. So if we find the maximum pairs that can be formed in a component, and remove from the total pairs we can form from the n, then at last the remaining thing will be the number of unreachable nodes, right? I know it's confusing. Let's try with an example. So now let's try the same implementation with an example. So as I said before, how many total pairs we can form, which is gonna be n into n, right? So but in this we're gonna get duplicate as well, because if there is 1 comma 2 a pair, we also gonna get 2 comma 1, and also we're gonna get a self pair as well, 1 comma 1. So we have to remove them. So first we're gonna find the total number of pairs, which is gonna be n into n. So now let's remove the number of self pairs, which is gonna be n, right? So the maximum self pairs we can get is the number of nodes in it, right? So for example, we have 5 here. So the number of self pairs is gonna be 1 and 2 and 3 4 and 5. Self pairs in the sense 0 comma 0 1 comma 1 2 comma 2 3 comma 3 and 4 comma 4. Those are self pairs. So at max we can get n, the number of nodes we have, those many number of self pairs we can get. So let's remove those self pairs. So now we remove those self pairs, right? So now let's remove the duplicates. So at max, how many duplicates can we remove? For example, let's say we have 0 comma 0 comma 1, 0 and 1. This is a graph. So if at all we have a pair called 0 and 1, then duplicate pair would be 1 comma 0. So there are 2 times, right? So for one pair there will be 2 times. So for the n pairs there will be 2n. So now we can remove the number of duplicate nodes by dividing this entire thing by 2. So now we can remove the duplicate pairs. So if you see clearly, we can form a formula here. So if you can see, this is gonna be n square minus n by 2, right? So now we can take this as n into n minus 1 by 2. So this many number of pairs we can form for n nodes without duplicates. So this is the formula. So now the main formula is, if we have total, then that can get the reachable nodes, the unreachable nodes, by removing reachable nodes from the total, right? So this is the main formula. In order to get the number of unreachable nodes, remove the reachable nodes from total, which is going to be n into n minus 1 by 2. So now let's find the reachable nodes in this graph. So now let's try to find the components. Components, as I said before, a component is nothing but the nodes which are connected to each other, and that's a component. So this is one component and this is one component. So let's find the number of nodes inside these components. So what I can do is, I can start from any of the node and start doing DFS or BFS. So I generally prefer DFS. So I can do DFS and find the number of nodes inside this component. So what I can do is, I can create an adjacency list. So based on a given edges, right? So I can create an adjacency list and I can maintain the number of adjacent nodes for a particular node. So for example, for this 0, we have 2 nodes adjacent to each other. So I can go to 1, right? So from 1, I can go to 2. I also have to keep track of the number of nodes I have traveled. So now up to 2, I have traveled 3 nodes, right? So from 2, I cannot go to any other node which are unvisited, because we have already visited 0 as well. So up to now the count is 3. So for this component, the number of nodes that are there are 3. So again, what I can do is find the maximum pairs I can form with these n nodes in this component. So which is gonna be our formula, 3 into 3 minus 1. So which is gonna be 6 by 2, which is gonna be 3. So at total, this is gonna be 3 pairs. So which is nothing but at total we have 5 nodes, right? So total, which is gonna be 5 into 5 minus 1 by 2. So 20 by 2, this is gonna be 10, right? So we can remove 3 from this 10, which actually means these 3 are reachable pairs. So if I remove 10 from this 3 from this 10, so this is gonna be 7. So now again, let's do DFS from this component. So for example, let's say we have a loop like 1 2 3 4 and 0. So we have started from 0, right, which is gonna be this. So now let's go to 1. So 1 is already visited before, so we cannot go to 1. And even 2, this is already visited before, we cannot go to 2. So now with this 3, so 3 is not visited. So let's start DFS from 3. So let's find the adjacent nodes. So current count is 1, right? So current count is gonna be 1. So let's start DFS from 3. So the adjacent node is 4. Let's go to 4. So the count is 2. So from 4 there are no adjacent nodes. So that's the end. So now by taking these 2, let's find the maximum pairs we can form. So it's gonna be 2 into 2 minus 1, which is gonna be 2 by 2, which is gonna be 1, right? So now we have to remove this 1 from this total. So as of now the total is 7 after removing the 3 from the previous component. Now remove 1 from this total, so this is gonna be 6. So now let's continue with the for loop. So now we are at 4 is already visited. So now we don't have any other nodes, which actually means we are pretty much done with this. So now the remaining thing which is present in this total is the number of unreachable nodes. Like we have formed a formula, right? So total pairs will be the number of reachable plus the number of unreachable. Yeah. So we can find the number of reachable. If you remove the reachable from total, for example, let's say we have unreachable, and if I remove number of reachable from this total, we get the number of unreachable, right? So whenever we're getting the reachable nodes from each component, we are removing them from total here. So the remaining would be the number of unreachable. So now the remaining in this total will be the number of unreachable. So for this graph, the number of unreachable pairs are 6. So now let's find what are those unreachables. So let's erase them. So now what are those unreachables? We can say 0 comma 1, I mean not 0 comma 1, 0 comma 3. I can say 1 comma 3. I can say 2 comma 3. I can say 0 comma 4. I can say 1 comma 4. I can say 2 comma 4. So these 6 are the unreachable pairs. So this is how we generally find the number of unreachable nodes in an undirected graph, or unreachable pairs in an undirected graph. Now let's try to implement this. So now we are having a method called as count pairs, which are having parameters n and edges. So n represents the number of nodes inside the graph and edges represents the edges. So the return type is long, so we have to return the number of unreachable pairs in this graph. So let's first things first, let's create an adjacency list. So adjacency list is nothing but where we can store the adjacency nodes for a particular node. For example, for 0 the adjacency nodes are 1 and 2, like that. So for that we have to store them at particular place. So I'll be creating an adjacency list which will be in the form of a list inside a list. So I'll be naming it as adj, which actually means adjacency list, adjacency. So adj gonna be an array list. So now I'm going to add n new lists to this adjacency list, because I can add the, for example, let's say we have three lists inside the list. So for like this, so 3 1 2 3. So this is at 0, right? So 0 1 and 2. So for the adjacency nodes for 0 are 1 and 2, right? So at the 0th index I'm going to add 1 comma 2. For the adjacency nodes for 1 are 0 and 2, right? For the word for 1th index I'm going to add 0 and 2. So similar way I have to create like that. So I'll be first adding the n list inside the adjacency list. So for n I is less than n I plus plus, I'm gonna add new array list inside this. So now I'll be iterating through this edges list. So this is gonna be an edge which will be taken from edges. So now u, or let's take a is gonna be edge of 0 and b is gonna be edge of 1. So now I'll be taking a adjacency list which is present at 8th index and add b to it. And similarly, as this is an undirected graph, I'll be taking the list from bth index and add a. So now let's find the total number of pairs we can form. As I said before, how can we find total number of pairs? So that's gonna be n into n minus 1 by 2, right? So but as there is, the n is very large, so there might be something like exceeding the limit of integer. So we have to make sure this is long as well. So even here when you multiply them, so there might be a case, so you have to make sure this is long. That's very important, or else the code doesn't work. It might work for few test cases, but it doesn't work for all. So now let's try to remove the reachable nodes from these total pairs so that we can get unreachable nodes. So how do we find reachable nodes? We have to find the number of components and number of nodes inside those components. So let's do this. Let's do a for loop from 0 to n minus 1 and start doing DFS from there. As I said before, we'll be starting from 0 or any other node. For this case we are starting from 0 and go to all the adjacent nodes from the 0. So if current node is not visited, then only we have to make DFS. So for keeping track of the visited and unvisited nodes, I'll be using a boolean array. which is gonna be visited. So visited is gonna be a boolean array of size n. So the way it works is, if at all visited of I, we are using the indices as nodes. So if visited of I is false, then do GFS from I. So now what this GFS is going to do, this GFS is going to return the number of nodes inside the component. So this is gonna take parameter as a node, and first thing first, we have to visit that node, right? So now go to its adjacent nodes. For int v adj dot get u. So we are trying to extract the adjacent nodes from the adjacency list. So as I said before, for 0 adjacency nodes are stored in the form of 2 5. So when we ask adj dot get 0, this is going to send a list which contains 2 and 5, like that. So now we have to go to the adjacent node only if it is not visited, right? So if not visited of v, then visit that that particular node. And one more thing, we have to return the number of nodes in this component, right? For that, I'll be maintaining a count. So for now the count is 1 because we have a current node, the count is 1. So we have to add the count for the ones which is written by the future nodes. So for example, let's say we have count 1 for 0, so this might return something else, this might return something else. So if we add these, we're gonna get the number of components in these nodes. We are basically finding the number of nodes inside a component. So now let's return the count. So this is how we find the number of nodes inside a component, and we are going to extract them here. So let's say this is going to be int let's say nodes. So now how many pairs we can form? We can form, as I said before, n into n minus 1 by 2. So now there's a formula for that, and most important thing, we have to use long so that we don't get any exceeding situations. So nodes star nodes minus 1 by 2. So now remove these pairs from total, so that we are removing the reachable pair from total, so that we get unreachable pairs. So now at last we are going to return the total. So this is pretty much the solution. So let's make sure we don't get any compilation errors. Let's try to run this code, hope for the best. Oh yeah, this worked. Let's try to run with some test case as well. Yeah, let's try to submit this. Yeah, it got succeeded. So this is how you find the number of unreachable pairs in an undirected graph. So there might be some other solutions as well for this. Like while I was writing the contest, so initially I wasn't getting, like I wasn't able to get that because I've missed this condition which is long. So this is very important case. So there are few other solutions which are done using union find algorithm as well. So but I felt this was a bit easier and understandable, so I thought of explaining this. So if you find any more optimal solutions, please try to comment it down. So please try to share this video, make sure you like and subscribe. Thank you.